This video is going to talk about ratio tables, and our essential question is, how do we use ratios to complete ratio tables and make coordinate graphs? And of course, we've been working with ratios for a few weeks now, and we know that they are comparisons of two numbers or quantities. And as we've worked with ratios, we've often looked at equivalent ratios. And one thing that we can do with equivalent ratios to organize our thinking is to put them into rate or ratio tables. In our ratio for a recipe, right, if we have 4 flours for every 3 sugars, then we know that our ratio is 4 to 3. And we can use this table to organize our thinking if we're trying to find a missing value when we know the other part of the ratio. If, for example, we know that there are 6 cups of sugar, like we see here, right? We'd say, well, that means I have 6 cups of sugar, right? I've doubled the amount of sugar. I therefore need to double the amount of flour that I would need to correspond, right? To keep it equivalent. So I'd say, oh, well, that means I must have 8 cups of flour. And what mathematically we're doing with our table is saying, well, this I doubled. So I'm also going to double the amount of flour to keep it the same ratio. And I can fill in the rest of my ratio table by looking for other similar patterns. So if I know I went from 4 cups of flour up to 20 cups of flour, I have 5 times as much flour. So in my ratio table, I need 5 times as much sugar, and so I would need 15 cups of sugar. And I could look at my table in other ways to help me as well. So maybe instead of going back to my original base ratio, I can look and say, oh my goodness, from 6 to 24, I have 4 times as much sugar. So I'm going to find the corresponding ratio here and do 8 times 4 and say that's 32 cups of flour. It's just a way to kind of keep everything in one place to organize our equivalent ratios. When we do art, we often use ratios as well. So if you're mixing to make a purple paint, you would use blue and red paint mixed together. And perhaps that ratio would be 3 parts blue for every 2 parts red. So the ratio is 3 to 2. Take a moment and look at the ratio table that I created. I wrote it horizontally, but it works the same way as the one that we just did previously that was vertically aligned. So you'll go ahead and think about, well, if this was twice as much blue, I would need twice as much red, and that would mean I need 4 cups of red. Pause the video and think about what you think would go in these spots. Go ahead and maybe make the table for yourself, right, and fill that in. How'd you do? Did you notice, for example, that this 2 times 5 made 10? So I had to do 3 times 5 to keep it equivalent to make 15. And maybe from there you realize that if I double that, I get 20. So I need to double my red to get 30, right? So you can use that ratio table to fill in the missing equivalent ratios. And sometimes once we have this information, we actually end up graphing it on a coordinate plane, which is what I've set up here with you on my page. So you can see I have blue. I'm going to have this as my x value. Typically the one that's first in our table would be our x. And I'm going to use red as my y value. So x and y are labeled along with my numbers written on those lines. And these ratio pairs end up becoming our coordinate pairs. So I'm going to graph 3, 2, because it's 3 blue and 2 red together. And I can graph 6, 4. I can graph 12, 8. I can graph 15, 10, 21 and 14, and 30 and 20. They become the pairs that I can then graph. And let's see if you remember how to graph these. So I'm going to go over to 3 on my x and up 2 on my y. So I'm going to go over 1, 2, 3, and then up 1, 2, and put a point there. I'll do the same thing with the next one. 6, 4, I go over to 6, which is here, and up 4, and mark that one. And I think I have room for one more. I can go over to 12 on my x, and up to 8 on my y, and mark it there. Now I can't fit any of the others on the graph, but I have enough information here to draw a straight line through all 3 points And I also went ahead and included a point here at 0, 0, because if I have no red paint, I wouldn't need any blue paint, right? I wouldn't have any paint to make. So I'm gonna go ahead and make a line through there. One more thing to mention is that ratio tables are useful when you're comparing ratios of two different items. And I'll show you an example. If we have two different juice mixes and we know one has a ratio of 3 cups orange for 5 cups water and the other has 4 cups orange for 6 cups water, we might want to know which one is the most orangey, meaning which one has a stronger orange flavor, right? And it might be hard to tell. Take a moment and think for yourself and guess which one you think would taste more orangey, and then we can build a ratio table to figure it out. I'm going to start by growing this table, right? So I'm going to have twice as much orange, so I need twice as much water. If I have another 3 cups of orange, I need another 5 cups of water, right? Every 3 cups of orange matches up with 5 cups of water. And let me do a few more. Let's see, I would make this 20. 3 more cups of orange would make 5 more cups of water. 3 more cups of orange, I need 5 more cups of water. I'll pause there for a second. And I'll do the same thing on the other. So I know if I have 8 cups of orange, I would need 12 cups of water. 12 cups of orange would use 18 cups of water. 16 cups of orange, 24. 20 cups of orange, I need 30 cups of water. And actually, I'm going to stop there because I noticed these both have 30 cups of water. For your turn, I want to think about the Portland Timbers and the Portland Thorns, and I want to think about which team was better at scoring goals. So the Timbers have a ratio of 2 goals in every 3 games, and the Thorns have a ratio of 5 goals for every 7 games. And I want you to build your table so that we can look at it together. So make sure you write it down, and then use that table to prove which team was better at scoring goals. And remember, this video covered a lot, right? We talked about why we make ratio tables and how to make them. We talked about how to use those to make graphs, pretty briefly. And then we talked about how to use those to compare ratios. So there was a lot going on in here. So we have a lot to talk about together in class. Be sure to bring your questions with you.